All right, today we're diving into something pretty wild, a new class of super materials that could completely change the game. I'm talking batteries that charge in minutes and clothes that are smarter than our phones. And no, this isn't some far-off science fiction. This is real, and it's the start of a massive materials revolution.
I mean, just think about that for a second. What would that even look like? No more lugging around those bulky power banks, right? No more being tethered to a wall for hours waiting for your phone to charge. We're talking about thin, flexible power that could literally be built into, well, just about anything. And what about this? What if your jacket could just block all unwanted electromagnetic signals? Or imagine a t-shirt that keeps track of your health in real time. These aren't just cool ideas from a movie. These are actual possibilities being unlocked right now by what is honestly one of the most exciting discoveries in materials science in a long, long time. So let's get to it. What are these magic materials? Well, they're called MXenes. And they're not just one thing. That's the key. It's a huge family of 2D super materials, and they are right on the edge of making that leap from the research lab into our everyday lives. Okay, so what exactly are MXenes? The name is pronounced MXenes, by the way. They were first created back in 2011 at Drexel University. Now, you can think of them as these super, super thin sheets, just atoms thick. You've probably heard of graphene, right? It's kind of like that, but with a huge twist. Graphene is just carbon. MXenes, on the other hand, can be made from tons of different metals mixed with carbon or nitrogen. This means you can basically custom build them, giving them this incredible range of properties. So what makes them so special? Why all the hype? Well, it's this killer combination of properties. They conduct electricity just like a metal, but they're also super strong and flexible. And here's a big one, especially for manufacturing, they're hydrophilic. That's just a fancy way of saying they love water. And because of that, you can easily turn them into inks and coatings. That, my friends, is a massive, massive advantage when you want to actually make stuff with them. Okay, so this all sounds amazing, right? But it brings us to the big but, the huge challenge. Look, from an industrial engineering perspective, a wonder material is completely useless if you can't make a ton of it safely and cheaply. And for years, this manufacturing puzzle has been the number one thing holding MXenes back. The way they first made MXenes, it was a total deal breaker for any kind of factory production. It involved using some seriously nasty stuff like hydrofluoric acid to etch away the layers they didn't want. Now, sure, that works fine if you're a scientist in a lab making a tiny little bit, but there is no way you can build a safe, affordable, large-scale production line around a chemical that dangerous. Just not going to happen. But here's where the story gets really exciting. In just the last few years, researchers have had these incredible breakthroughs. They finally cracked the code, figuring out ways to make MXenes that are safer, cheaper, and, you guessed it, finally ready for the assembly line. So instead of those toxic acids, they've found much cleaner ways to do it. There are new techniques like dry selective etching, which uses things like special gases or even molten salt to peel away those unwanted atomic layers with incredible precision. And what you get? Pure, high-quality MXene sheets, but without all the hazardous waste. This is what finally makes mass production a real possibility. And if that wasn't enough, there's a secret weapon accelerating all of this: artificial intelligence. I mean, think about it. Instead of a scientist spending years in a lab mixing and matching things with trial and error, AI can simulate thousands of potential MXene recipes in a fraction of the time. It can predict what their properties will be, helping researchers zero in on the perfect material for any job, whether it's for a new kind of battery or medical sensor. It's like having a supercomputer for materials discovery. So, with this huge manufacturing bottleneck finally breaking open, we are right on the edge of a genuine MXene revolution. So, let's get into the good stuff. What does this actually mean for the tech we all use every single day? Okay, first up, and this is a big one, energy storage. And listen, we're not just talking about making our phone batteries last a little bit longer. This is about completely rethinking how we store and use power. So because of their unique flat 2D structure, they have this massive surface area. Think of it like a superhighway for energy. It gives the ions, the things that carry the charge, tons of room to move around really, really fast. And that means MXene-based batteries can charge and discharge at incredible speeds. Yeah, we're talking about charging your devices in minutes instead of hours. And since they're flexible, you can mold them into almost any shape. This opens up a whole new world of self-powered electronics. And that flexibility, it leads us straight to the next huge frontier:
We're talking about electronics that aren't just solid bricks you carry in your pocket, but things that are literally woven into the fabric of the clothes you're wearing.
Remember how we said MXenes are water-loving or hydrophilic? Well, that's the key here. It lets scientists create these really stable conducting inks, and you can use those inks in like a regular printer to just print circuits, antennas, and sensors right onto fabric. I mean, picture a t-shirt that's constantly monitoring your heart rate, or a jacket with a heating system powered by a battery that's literally part of the clothing. It's amazing. Okay, so beyond wearables, there's another really unique property of MXenes. It's how they interact with electromagnetic waves. And in the world we live in today, which is just full of signals, this has some massive implications. So get this. MXenes are absolutely incredible at shielding against electromagnetic interference. A tiny film, way thinner than a single human hair, can block more than 99.999999% of incoming signals. That's insane. In a world that is just jam-packed with wireless signals flying everywhere, that is so critical for protecting sensitive electronics, everything from our 5G networks to crucial life-saving medical equipment. But you know, the impact here goes way beyond just our cool new gadgets. Their unique surface chemistry also makes them this incredibly powerful tool for tackling some huge global challenges, like cleaning up the environment and pushing forward advanced medicine. Let me give you a couple of examples. That water-loving property and their layered structure, it makes them perfect for building next-gen water filters that can pull the salt out of seawater really efficiently. And in medicine, the fact that they're biocompatible, meaning safe for the body, is a huge deal. Some types of MXenes can absorb light and turn it into heat. This could allow doctors to use them in therapies to target and basically cook cancer cells with pinpoint accuracy without harming any of the healthy tissue around them. It's just revolutionary stuff. So, if there's one thing to take away from all of this, it's that we are not talking about some far-off, distant future. This isn't science fiction anymore. MXenes have already made that critical jump from being a cool thing in a lab to a real material that's ready for the factory floor. I mean, just look at this timeline. You can see just how fast this has all happened. We're talking about going from the very first discovery to solving the massive manufacturing problem in just over a decade. That's lightning fast in the world of materials science. And today, the focus is all on commercial-scale additive manufacturing, which is really just a fancy way of saying 3D printing with these amazing MXene inks to build the electronics of tomorrow. And believe it or not, the potential is still growing. I mean, on the absolute cutting edge, scientists are looking at using MXenes to create artificial synapses. These are little components that act just like the neural connections in our own brains. This could literally pave the way for a whole new kind of computing, incredibly powerful, super efficient computers that are modeled after our own biology. So it really makes you think, right? As this super material starts to scale up, what's the first thing in your life that it's going to transform? Will it be the phone in your pocket? The jacket on your back? Or the medical tech that keeps us healthy? Whatever it is, one thing is for sure. MXenes are coming. The era of 2D materials isn't a lab experiment anymore. It's a manufacturing reality, and it's about to change everything. Thanks for joining me.